The problem we are going to solve today is the equation 4 to the power of x minus 2 is equal to 40. We have to find the value for x. First, I will show you how to solve this problem the fastest and the most efficient way. I want to remind you of the definition of a logarithm. So a to the power of b is equal to c. We have exponents, as you can see, and by the definition of a logarithm, b is going to be a logarithm of number c for the base of a. By using the definition of a logarithm, the equation 4 to the power of x minus 2 is equal to 40 is going to be transformed into x minus 2 is equal to a logarithm of 40 for the base of 4. And then x is equal to 2 plus a logarithm of 40 to the base of 4, and this is the final solution. A little note which I want to make here is that although this is the right approach to solve this problem, I want to make a little bit of an exercise for the properties of a logarithm for this problem. So we are going to solve it again. Equation is 4 to the power of x minus 2 is equal to 40, but this time we are going to use the properties of logarithm, not its definition. So I want to remind you of the rule of exponentials. A to the power of m minus n is going to be equal to a to the power m divided by a to the power of n. By applying this rule to our equation, it becomes 4 to the power of x divided by 4 squared is equal to 40. This is equivalent to 4 to the power of x divided by 16 is equal to 40. And what we can do now is multiply an entire equation by 16. That way we get 4 to the power x to be equal to 40 multiplied by 16. And now we are going to take a logarithm of both sides of the equation. So we have that a logarithm of 4 to the power of x is equal to logarithm of 40 multiplied by 16. And remember the convention, when we don't write anything for the base of a logarithm, the base is equal to 10. Let's now apply the property of a logarithm, that a logarithm of a to the power b is equal to b multiplied by logarithm of a to the left side of the equation. Then we get that our equation is x multiplied by log of 4 is equal to logarithm of 40 multiplied by 16. We can divide an entire equation by log of 4, and in that way we get that x is equal to log of 40 multiplied by 16 divided by log of 4. At this point we can apply a rule of a logarithm which states that logarithm of a multiplied by b is equal to logarithm of a plus logarithm of b. By applying this rule, this term here gets transformed into logarithm of 40 plus logarithm of 16 divided by logarithm of 4. And this is equal to logarithm of 40 divided by logarithm of 4 plus logarithm of 16 divided by logarithm of 4. As you know, 16 is equal to 4 squared. So we can use that. And x is equal to logarithm of 40 divided by log of 4 plus logarithm of 4 squared divided by logarithm of 4. We can use again the rule of the logarithm, that logarithm of x to the power n is equal to n multiplied by logarithm of x, and then we get that this is equal to logarithm of 40 divided by log of 4 plus 2 logs of 4 divided by log of 4. And these 2 logs of 4 are going to cancel out. And we are left with 2 plus logarithm of 40 divided by log of 4. At this point, you can notice that 40 is equal to 4 multiplied by 10, and that is what we are going to use next. So x is equal to 2 plus logarithm of 4 multiplied by 10 divided by log of 4, and this is 2 plus logarithm of 4 plus logarithm of 10 divided by logarithm of 4. And of course, I have used this property of a logarithm again. So this is then going to be equal to 2 plus logarithm of 4 divided by logarithm of 4 plus logarithm of 10 divided by logarithm of 4. And this entire fraction is going to give us the value of 1. So this is 3 plus log of 10 divided by log of 4. The catch here is to express number 10 as 2 multiplied by 5. And of course, we can express 4 as 2 squared. So x is going to be equal to 3 plus logarithm of 2 multiplied by 5 divided by logarithm of 2 squared. So we have 3 plus log of 2 plus log of 5 divided by 2 logs of 2. So this is equal to 3 plus log of 2 divided by 2 logs of 2 and plus log of 5 divided by 2 logs of 2. This entire fraction is going to be equal to 1, and we have 2 here in the denominator, and we have then 3 plus 1/2 plus 1/2 log of 5 divided by log of 2. At this point, we cannot simplify this term any further. So we are just going to use another property of a logarithm, which states that logarithm of a divided by logarithm of b is equal to logarithm of a for the base b. Then x, by using this, becomes 3 plus 1/2 plus 1/2 logarithm of 5 for the base of 2. So this is then going to give us that x is equal to 7/2 plus 1/2 log of 5 for the base of 2. And this is going to be the final solution in this case. So the solution that we have is x is equal to 7/2 plus 1/2 logarithm of 5 for the base of 2. And now for the additional practice, we are going to check if the solution that we have is correct. We are going to do that by returning the value which we have as a result for x in the equation that we have started from. So x is equal to, we can write this just as 7 plus log 5 for the base of 2 divided by 2, and we are going to plug that into the equation. 4 to the power of x minus 2 is equal to 40. So we have that 4 to the power of 7 plus logarithm of 5 for the base of 2 divided by 2 minus 2, and our goal is to prove that this is equal to 40. This equation has to be proven. And in order to prove that the equality holds true, we are just going to calculate this term. If we get the value of 40, then the equation is satisfied. So this term is going to be equal to 4 to the power of 7 plus logarithm of 5 for the base 2 divided by 2, and 2 multiplied by 2 is 4, and we have a negative sign in front of it. So this is 4 to the power of 3 plus logarithm of 5 for the base 2 divided by 2. This is then equal to, we can represent number 4 here as 2 squared, and that is going to be raised to the power of 3 plus logarithm of 5 for the base 2 divided by 2. Here I am going to use the properties of exponents. So the properties of exponents are a to the power of m to the power of n is equal to a to the power of m multiplied by n. So this is going to be equal to 2 to the power of 2 multiplied by 3 plus logarithm of 5 divided by 2, and these 2's are going to cancel out. So we are left with 2 to the power of 3 plus logarithm of 5 for the base 2. This is going to be equal to 2 cubed multiplied by 2 to the power of logarithm of 5 for the base of 2. And this is going to be equal to 8 multiplied by and 2 to the power of logarithm of 5 to the base 2 is just going to be equal to 5. So this is going to be multiplied to 5, and at the end it gives us the result of 40. Of course, in this position here, I have used the property of a logarithm. A to the power of logarithm of b for the base of a is just equal to b. And this number 40 here, which we got, is exactly what we have needed. So the result which we have for x is the correct solution. So thank you for watching, and I'll see you in the next video.